Here's why the Omni setting on your studio condenser isn't quite Omni, and why that matters for your music production. To demonstrate this, I'm using a cheap speaker to generate full spectrum noise, and we're watching the frequency analysis of the Vanguard V4 FET condenser. The V4 is on Omni mode, but you can see the same effect with cardioid or figure 8. Carefully watch the high frequency area of the response of the frequency analyzer. Watch when I shift the microphone from 90 degrees to facing the speaker and how much the high frequency changes. The nerdy reason for this is called angle of sound incidence. To understand this, we have to understand how sound works in air. Sound waves are the bunching and diffusing of air particles. The denser parts are called compression, and the less dense parts are rarefaction. Most condenser microphones are pressure microphones where they measure the air pressure at the capsule in a given moment. When the diaphragm is straight on to the incoming airwaves, the pressure at any point on the diaphragm is the same. But when we turn the diaphragm at an angle to the incoming waves, or the angle of sound incidence, the pressure at any 2 points will be different. For low frequencies like the one on the left, the wavelength is so wide that the pressure difference at those 2 points is minimal. At higher frequencies, we can see that the pressure is drastically different at 2 different points, and so the total sum across the entire diaphragm is getting canceled out. So that's why as we turn the microphone, we're seeing those high frequencies get rolled off. This can be used to your advantage as an engineer when miking sources by changing the angle of the mic for a natural high-end EQ. Join Winnie and I next week when we talk about how tube microphones work.